We're starting the second half of our unit. It's on 6b, which is logarithmic functions. Previously, we spent chapters 8.1 through 8.3 covering exponential functions. This was unit 6a. Now we're going into logarithmic functions, which still deal with exponential functions, but in a different way. If you remember correctly, when we were doing the compound interest problems, and I gave you all the information, but needed to find t. So we had some basic, $1,500 was what I wanted. I started with 1,000. I had some number, 1 plus 0.04 over 12 to the 12t. And we needed to solve for t, so we put this entire function into y1, and we put this entire function into y2. And then we went through, we found the intersection of some graph that, looked like this and a horizontal line, and the x value was t. Well, the reason why we used our calculator is because we didn't know how to do it. We didn't know how to find t. Take, for instance, I know how to find 2 squared. 2 squared is 4. I know 2 cubed is 8. But what happens when I ask for 2 to the x power and I know it equals 6? I know looking at 2 to the second, which is 4, and 2 to the third, which is 8, and I want something 6, which is in between 4 and 8. Our x has to be in between 2 and 3. But I want to know exactly what it is. And that's where logarithm functions came into play. Logarithm functions were invented to be able to find this. It was invented to find the inverse of exponential functions. So you'll see logarithms a lot. You'll see them in Algebra 2. You'll see them in Pre-Cal, and any other time that you're dealing with exponential functions. So I want to start by first giving you the definition of a logarithm with base b. So I advise you to write this down. We're going to let b and y be positive numbers. And b cannot equal 1. All right, assuming this is true, the logarithm of y with base b is denoted by log base b of y and is defined as, so let b and y be positive numbers and b not equal to 1. The logarithm of y with base b is denoted by log base b of y, and that's pronounced log base b of y. So this is my base, log base b of y, and is defined as log base b of y equals x if and only if b to the x equals y. This is a really important definition. You're going to use it a lot. So if I am given b to the x equals y, and I want to know what x is going to be equal to log base b of y. What this tells us is that log base b of y equals x if b to the x power equals y. It tells us that these two things are equivalent. This is in logarithmic form, and this is in exponential form. So if I gave you an equation in one of these two forms, you should always be able to rewrite it in the other form. and hopefully then be able to solve it or figure out what you're trying to do. So looking at some examples, I'm giving you some logarithmic forms and I want them to be written in exponential form. Going back to what we just learned, we have to remember log base b of y equals x if and only if b to the x equals y. You really need to memorize this. So if I'm given log base 2 of 32 equals 5, here's my b, here's my x, so 2 to the 5th, b to the x, equals 32. So I can rewrite this as 2 to the 5th equals 32. All right, and if we look at that, 2 to the 5th is 32, so that's true. Looking at this example, base is 5, so 5 and x is 0. 5 to the 0th equals 1. We know that's true too. I want you to pause this video and try the last three on your own. Okay, the last three. 10 to the 1st equals 10. 10 to the negative 1st equals 0.1. And 1/2, you should always put that in parentheses, to the negative 1st equals 2. So this shows us how to rewrite logarithmic equations into exponential form. So two of those previous examples had important information that create special logarithm values. These are important to remember because when we're solving, things can be easier when we know this rule. So assuming b is a positive real number and b doesn't equal 1, we've got two special logarithm values. One is the logarithm of 1. Logarithm of 1. And that says that log base b of 1 is going to equal 0. And that's because if we put it in our special exponential form, our special conversion, I guess, b to the 0 equals 1. So know that if you are finding any base, no matter what it is, of 1, that's always going to equal 0. The other one we have is the logarithm of base b. And that says that if I find the log of base b of b, so basically my base and my number are matching, they're the same number, that's going to equal 1. And this is because b to the 1st is always equal to b. So I would understand these two rules. You don't need to know the names of them, but it's important that if you ever see 1 here, you know it equals 0. And if these ever match, it equals 1. We will be using these rules a lot. So let's look at some examples where we're going to have to evaluate the expression. These are some of the problems that you're going to have to solve. And let's start with log base 3 of 81. Well, we know that's going to be equal to x. So I can rewrite this as 3 to the x equals 81. And I'm trying to find out what x equals. Well, remember, equivalent exponential functions, if they have the same base, like 2 to the x equals 2 to the 2nd, the only way for these to be equal is if our exponents are equal. So if we were given this, we would know x equals 2. Therefore, in this case, 3 to the x equals 81. How can we write 81 to have a base of 3? Well, hopefully you're thinking to yourself 3 to the 4th. Therefore, x equals 4, and therefore log base 3 of 81 actually equals 4. Looking at another example, we have log base 5 of 0.04. We know that's going to equal x, so we want 5 to the x equals 0.04. Well, another way to look at 0.04, remember that's 4 over 100, which if we divide by 2, or actually if we divide by 4, is going to be 1 over 25. So another way to write this is 5 to the x equals 1 over 25 to the first. Well, that's still not going to help us totally yet, but we can still change it. I want this 25 to deal with 5. 5 to the x is 1 over 5 squared. Well, remember, 1 to any power is going to equal 1. So the same thing would be 1 squared over 5 squared. Therefore, 5 to the x is going to equal 1 over 5 squared. Well, the equivalent of this is 5 to the x equals 5 to the negative second, because remember, negative exponents, you take the reciprocal. Therefore, after all that, we know x is going to equal negative 2. And then we know the logarithm of base 5 to the 0.04 is negative 2. I now want you to pause the video and try these other two on your own. Alright, hopefully you've tried these. So looking at this first one, we know 1/2, put it in parentheses, to the x power, because we want to find out what this equals. It's going to equal 8. Well, that's the same thing as 1/2 to the x power equals 2 to the third. So if I have 1/2 to the x, to get this 2 to be 1/2, I'm taking the reciprocal, so this is going to be negative 3. Therefore, x equals negative 3, and therefore log base 1/2 of 8 equals negative 3. Finally, for the last problem, we have log base 9 of 3. We want to know what it equals, so 9 to the x equals 3. Well, remember, 9 is the same thing as 3 squared to the x power, which equals 3 to the first. This is the same thing as 3 to the 2x equals 3 to the first. So I know 2x is going to equal 1. Divide by 2, x equals 1/2. Therefore, log base 9 of 3 is going to equal 1/2. You might have solved it a different way. That's okay. But I would learn that the goal of these problems is to change to get them to have the same base. This will be crucial as we keep doing these. So try and get into the habit of changing it, with your ultimate goal always being of having the same base. The last important part to cover for this particular lesson is common logarithm and the natural logarithm. A lot of times you might see something like log 15. There's going to be no base written. That's because a common logarithm is a logarithm with base 10. It's our standard logarithm, so it's usually, even rather than being denoted as log base 10, it's just written as log. So if you ever see a log without a base, the 10 is implied because it's a common logarithm. Remember when we studied exponential functions, we also learned about the natural base, e. And we learned, e to the 1.5, e to the x, and we graphed them, we solved them. It was the natural base. Therefore, we need to have a logarithm that deals with that. When we have log with a base of e to the x, that's called the natural logarithm, and it's denoted with an ln of x. So if you see ln, a base of e is implied, and rather than writing it as log base e of x, we use ln. But they are the same, and I want you to understand that. You're going to see both. The last important thing to learn that you need to know for our lesson is that you can use the calculator to solve some of these. So in the calculator, on the left-hand side, on the very bottom is the on button. Then above that is an STO button. Above that is the ln button. You can press ln, and it will pop up with an ln parenthesis. Put in your number, close the parenthesis, press enter, and it will give you the answer. Same thing above the ln button is the log button. Put log, it's going to come with log parenthesis. Do the same thing, put in whatever you want, close the parenthesis, and press enter. So you can use your calculator to calculate these. But be very careful. Read the directions when you do the work. Sometimes you're going to be allowed to use the calculator, and other times you won't. And you need to be able to how to do this with both.